Algebra Lesson 2-4, and we are on page 74. I'm looking at my book right here in front of the camera, and we will start by looking at the top of it. This lesson is on solving equations containing integers. So we're going to be using all of the same rules that we have used for solving equations, isolating the variable, finding out what it's equal to. We're going to be using all of those same approaches, but this time we're going to be doing it with positive and negative numbers. So we're going to be applying the things that we've learned in lessons 2-1, 2-2, and 2-3 about adding, subtracting, and multiplying and dividing with positive and negative numbers. And one thing I want to remind you is that in solving, if you have a subtraction problem like 6, let's say -6 minus 4, remember that I want you to rewrite this. And I'm going to move the camera a little bit closer. I'm sorry for the glare that you get. I hope that you'll be able to see everything okay. Remember that whenever you have a subtraction with integers problem, I want you to rewrite it. That changes to a plus. And because it was a subtraction sign there, it could not also be a negative sign. We used it as a subtraction sign, so this is a positive 4 sitting here, which needs to become a negative 4. Remember, we changed the type of math, and then we changed the sign on the second number. And so -6 plus -4 is -10. So just a quick review on that. You need to keep applying that in working these equations. All right, let me erase that. And let's get started. Now I'm going to stand here and just read to you for just a second. You can read along with me on page 74 at the top. When you are solving equations with integers, your goal is the same as with whole numbers that are like positive numbers in the past that we've been working with. Your goal is to isolate the variable on one side of the equation. Recall that the sum of a number and its opposite is 0. That means if we add 3 plus -3, it equals 0. If we add 100 plus -100, it equals 0. When you add the opposite to get 0, you can isolate the variable. So all that's talking about is the additive inverse that we've used in the past to get a variable alone, or if things were multiplied together, we would divide to get the variable alone. Or if things were divided, we would multiply to get the variable alone. So let me do a quick example of what they're talking about. X plus 7 equals 14. We would start solving this equation by getting x alone. So we're going to do the opposite of what's done right here, and that means we're going to subtract 7. So now it's -7, but whatever we do to one side of the equation, we must do to the other, so we do it on both sides. This crosses out. This is what they were talking about when they said, recall that the sum of a number and its opposite is equal to 0. So this gets canceled out because +7 plus -7, or +7 and -7 equals 0. So now we're left with x equals 14 minus 7 over here, which is 7. All right, that's all they're talking about there. Now I think we can move ahead to examples. We're looking at example 1, and it is y plus 8 equals 6. So let's look at this problem. Y plus 8 equals 6. Remember, we need to isolate this y. And we're going to do the same thing we've done many times before. We're going to do the opposite of what's done right there, and that's plus. So we're going to say -8. Whatever we do to one side of the equation, we must also do to the other. And that's when we run into new challenges. So first of all, let's notice that +8 minus 8 equals 0. So now we have y equals 6 minus 8. That's where the integers come in. Now we're dealing with positive and negative numbers because 6 minus 8 is going to be a negative number. So let's look at it right here. Or actually, let's go up. I need to make sure that this is in the camera. Is that? Yes. Okay. 6 minus 8. This is what I was talking early in the lesson about rewriting. So let's rewrite this as addition. So minus becomes plus, and this 8 becomes a -8. Remember, this minus sign right here cannot be a subtraction sign and a negative sign. We have to choose which one it's going to be. Since we're using it as a subtraction sign and we're going to do the opposite and add, we have a +8 sitting there that has to become a -8. And the answer to that is -2. So y is going to equal -2. Let's plug it back in and see if it works. Is -2 plus 8 6? It sure is. All right, let's look at the next example. Negative 5 plus t equals negative 25. Negative 5 plus t, I'm going to make my t look different than my plus sign, equals negative 25. Let me make sure you can see all of that. You know what, let me do bigger for you guys. Negative 5 plus t equals negative 25. Hopefully that'll help. Okay, our job is to get t alone. So we're going to do the opposite of what's done right here, which is a negative or a subtraction, and we're going to say plus 5. And whatever we do to one side, we must do to the other. This is going to cancel because a negative 5 and a positive 5 add to equal 0. We are simply left with a t on this side, and on the other side we have negative 25 plus 5. And I think you can do that one without rewriting it because it's already addition. And our answer is going to be negative 20. The reason for that is that when we have two different signs on our numbers, we find the difference. Remember, different signs when you're adding means find the difference. All right, so that's what we did. We said 25 minus 5 is 20. Whichever number was the largest, that's the sign we used. 25 was the largest and it's negative, so our answer is also negative. Now we plug it back in. Negative 5 plus negative 20 does in fact equal negative 25. All right, let's do another example. This is, let's see. Yeah, this is example C, or letter C in example 1. And it says x equals negative 7 plus 13. X equals negative 7 plus 13. Hold on. Yeah, okay, so we don't have to, we've already got our variable isolated because it's on the left side of the equation by itself. I was wondering if I had done it wrong, or written it wrong, but it's right. So we're gonna have x equals, and we need, because these have different signs, we need to find the difference between the two numbers, which is going to be 6, and then that 6 gets the sign of whichever number was bigger, which is positive. So positive 6 is equal to negative 7 plus 13. All right, let's move on down to example 2. Multiplying and dividing to solve equations. So we're going to be using our rules that we learned in lesson 2-3 about multiplying and dividing integers, or multiplying and dividing positive and negative numbers. This one is k divided by negative 7. K divided by negative 7 equals negative 1. All right, let me make sure I've got this in the camera. Yes, okay. K divided by negative 7. I'm going to stand this up and see if I can get it a little bit past that one reflection. Maybe if I move it down. It seems like no matter where I put it, it's still going to be in the reflection for you guys. Okay, I don't know if that'll help any, but we'll try it down lower. All right, so here we need to get k alone, but this is a division problem. The opposite of the division is multiplication, and we're going to multiply both sides by that negative 7 to get it off the bottom. So we say times negative 7, and remember those cancel out to become a 1 or 1k, but that we don't have to put it, it's just understood. But whatever we did to one side, we now have to do to the other, and k equals negative 1 times negative 7. Do you remember the rule? Go back and look at lesson 2-3 if you need to review the rules. Whenever we multiply two things with the same sign, it's always positive. Or we can say a negative times a negative is always a positive. So this answer is 7. Negative 1 times negative 7 is positive 7. Is 7 divided by negative 7 negative 1 if we plug it back in? Yes, sure is. All right, let's look at the next one. Let's see. Negative 51 equals 17b. Negative 51 equals 17b. All right, here we need to isolate our variable, and we need to get b alone. So we are going to do the opposite of what's done. These are multiplied together, remember, because they're butted up against each other. So we need to divide both sides by 17. Here, this is going to cancel out and become a 1b, or we'll just leave it as a b. We're left with b on the right side. And over here, we have negative 51 divided by 17. 51 51 divided by 17 is 3, and a negative divided by a positive is a negative. Remember, when we're multiplying and dividing, if we have two different signs, the answer is always negative. So a negative divided by a positive is negative, and a positive divided by a negative is negative. All right, I'm checking the time to see how we're doing. We're doing okay. Okay, the last thing we need to do is look at the word problem at the top of the next page. This is page 75, and I'm going to have to move through this quickly to make sure that my video, it doesn't get too long to upload, so y'all bear with me. Pause the video if you need to kind of process what I'm saying, or go back and replay parts of it if you need to. All right, this is example 3. Net force is the sum of all forces acting on an object. Expressed in newtons, that's just our measurement, it tells you in which direction and how quickly an object will move. If two dogs, you'll see the two dogs in the picture, if two dogs are playing tug of war and the dog on the right pulls with a force of 12 newtons, what force is the dog on the left exerting on the rope if the net force is 2 newtons? So we know that our total is 2 newtons. That's our, let me move it down because of the glare. We know that our total is 2. The left dog's force plus the right dog's force equals 2. So now let's think about this. Left dog plus right dog. When you have a word problem, it's helpful to either draw what your answer might look like or to write out what your answer represents, which is what I did in this case. My equation that I have to write is total, or 2 newtons, equals left dog force plus right dog force. So now I'm going to plug in what the problem tells me. 2, the total of 2, equals the left dog, which is, let's see, we don't know what the left dog is, so we're just going to put an F for the force of the left dog, plus the right dog's force. The dog on the right pulls with a force of 12 newtons. And we're not going to put our measurement, our newtons in here. We're just going to put our numbers, and then we'll label our final answer with newtons. But here is just an algebraic equation like all the other ones we've done. We just had to figure out how to get from the word problem to the algebraic equation. So let's isolate our variable. We're going to do that by doing the opposite of whatever's here. This is plus 12, so we're going to say minus 12. Whatever we do to one side of the equation, we must do to the other. Plus 12 minus 12 equals 0. So F is equal to 2 minus 12. Now let's go up here and work that. 2 minus 12. Remember, when you're subtracting integers, I want you to rewrite the problem as addition. 2 plus negative 12. Make sure you pause the video if you're not sure why I did that. We need to change the subtraction to addition, and we need to change the sign on the 12, which is positive because we used the negative as a subtraction sign. So the 12 is still sitting there as positive, and we've got to make it negative. So 2 plus negative 12 is negative 10. So F is equal to negative 10. Let's plug that back in. This is negative 10, the dog on the left. This is 12, the dog on the right. So we have 2 equals negative 10 plus 12, and that would be correct because 12 minus 10 is 2, and the bigger number is 12, which is positive. All right, I'm going to need to stop my video there so that it doesn't get too long. I hope that helps. Go back and watch it if you need to, review the lesson if you need to, and pause and process if you need to. Have a good day.